Hi, this is Miss Fitzmaurice, and this video is about Sohcahtoa and the Pythagorean theorem. Okay, so hopefully by the end of this video you will know why right triangles are important in physics, okay, how to find the sides of right triangles, and how to find the angles of right triangles. Alright, so far we've talked about things moving side to side, so you can probably remember SpongeBob, and he lived in this one-dimensional world where he basically walked back and forth on a number line. Okay, let's think about the following situation. Instead of SpongeBob walking back and forth, we have Iron Man, who you can see here pictured in his beautiful red Iron Man suit. And Iron Man is trying to throw an evil robot into the air in order to defend society or something. Whatever Iron Man does. But this evil robot is going to fly through the air, and as you can see, the evil robot, in its fly through the air, is both going side to side and up and down. Okay, what we're going to do, instead of just using x and x naught and v naught, we're going to break all of the motion into both side to side motion and up and down motion. And when you break motion into side to side and up and down, everything becomes a right triangle. So let's first think about the velocity with which Iron Man is throwing this evil robot across the sky. Okay, so his initial velocity is at some angle to the horizontal. Okay, I'm going to call this angle theta. You may or may not have seen theta in your math class. Your teacher may have used x or y for an angle, but in physics we usually use theta. It's just a Greek letter. It looks like an Easter egg with a cross in the middle. Okay, so this is theta. Let's say our angle in this case is 37 degrees. And Iron Man throws the evil robot at a 37 degree angle, and let's say he throws him at 20 meters per second. Okay, this is the initial velocity of our evil robot. We can also break, as I've done here, this velocity up into a right triangle. And so we could have an initial vertical velocity that's up and down, and we'd call that v naught y, and an initial horizontal velocity v naught x. And instead of going ahead and having x naught x, v naught v a t, we would have x and y. Okay, x is side to side, y is up and down, and we would break everything up into x's and y's. So we'd have x naught x, that's the initial side to side position, xx, v naught x, vx, ax, and then in the y direction we'd have x naught y, xy, v naught y, vy, and ay. Okay, so we can break all of our motion up into x's and y's, x being, again, horizontal or side to side, and y being vertical or up and down. Okay, that's why right triangles are important in physics. And it turns out that it's not just motion, but pretty much everything in physics can be broken up into side to side and up and down. So the next unit we'll do after this will be force, and you can imagine that the force that Iron Man is putting on this evil robot over here is not straight side to side or up and down, but also at an angle, and so you could break the force up into Fx and Fy. Okay, just like the initial velocity, you could have v naught x and v naught y, and the acceleration could be ax, the side-to-side acceleration, and ay, the up and down acceleration. Okay, so for this to be useful to us, we're not going to jump right into doing two-dimensional calculations in kinematics or in forces. We need to take a step back and think about how do we do this geometry. Okay, if I have a number for f and I have a number for fy, could I find fx? Okay, so that's what we're going to talk about next. Alright, so the next thing we're going to do is we're going to talk about how to find the sides of a right triangle. Before we do this, we need to introduce a few definitions. So you probably have heard of these in geometry, okay? But basically what you call the different sides of a triangle depend on where they are with respect to this angle theta, wherever that may be, and our right angle. Okay, and just in case you forgot, a right angle is a 90-degree angle, and it's always designated by sort of this square in the side. Okay, always, the side across from the 90-degree angle is called the hypotenuse. And again, you probably saw this in geometry in middle school about 100 times before. Okay, the side that is across from this angle theta is called our opposite side. And the one that's right next to this angle, so this one right here, is called our adjacent side. Okay, and I'm going to give these guys a name. I'm going to say, in this case, we have A, B, and C. Okay, the Pythagorean theorem says that A squared equals B squared plus C squared. So you could use this to solve for one of the sides. The other thing that you could use to solve for one of the sides are these three trig identities. Okay, and this is what Sohcahtoa stands for. We know that sine theta, and sine theta is just a button on your calculator, is equal to opposite over your hypotenuse. Cosine theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Alright, so here's our first example, and we have this triangle. We want to know what the third side is equal to. Okay, to do this, you're going to use the Pythagorean theorem, so a squared equals b squared plus c squared, and a has to be your hypotenuse. Okay, so I want you to take about 30 seconds, try to find me a value for x, and then check back in to make sure you're doing it correctly. Okay, so now that you have found a value for x, I will show you how to do the right answer. Okay, we know that our hypotenuse is across from the 90-degree angle. Okay, so 2 is our hypotenuse, so we have 2 squared equals b squared plus our second side that we know is 1 squared. Okay, we know 2 squared is equal to 4 equals b squared plus 1. We can subtract 1 from both sides, and we have 3 equals b squared. And what this means is that b is equal to the square root of 3. Okay, because we have to take the square root of both of these sides to get rid of the squared. Okay, the reason we use the Pythagorean theorem in this case is because we knew 2 of the sides, so we had enough information to plug into the Pythagorean theorem. The next example, we're not going to have that much information, and you'll need to use sine, cosine, or tangent. Alright, so in this situation you're going to have to use either sine, cosine, or tangent to find x. Before you try to solve, I want you to take 2 seconds and try to decide what my two sides, 10 and x, are. Are they the hypotenuse, the opposite, or the adjacent sides? Okay, so because 10 is across from a right angle, it's not drawn in, but you can tell it's the one that is 90 degrees. 10 is our hypotenuse, and x, it's right next to the 37 degrees, our theta, so that is our adjacent angle. Okay, if I want to find x, what that means, and I'm going to write Sohcahtoa up here, I have adjacent and hypotenuse. Adjacent and excuse me, hypotenuse. What that means is I am going to use cosine. Okay, so I have cosine theta equals adjacent over hypotenuse. I'm going to plug in my 37 degrees, so I have cosine 37 equals, my adjacent is x, so I just put an x over 10. I can multiply through, so times 10 times 10, these cancel out, and I have 10 times cosine 37 is equal to x. When I plug that into my calculator, I find that cosine 37 is 0.8, and so 10 times 0.8 is just 8, and my x is equal to 8. Alright, so here's another example. I want you to take a minute, try to identify 5 and x, whether they're the hypotenuse, opposite, or adjacent, and then decide whether you should use sine, cosine, or tangent. Okay, so now that you've taken a second, we know that x is across from the 30, so that is our opposite. 5 is right next to it, so it is adjacent. And if I write out Sohcahtoa, I know I have the opposite and adjacent, so that's O-A, and I need to use tangent. I have tan 30 equals opposite over adjacent. Try to find me a number for x, and then check back. Okay, so now that you have tried that, you have tan 30 equals opposite, which is x, over 5. We can multiply through with the 5s to cancel out the 5 on the bottom, or in the denominator, and we have 5 times tan 30. And if you plug that into your calculator, you should end up with x is equal to 2.89. Alright, so say we want to find an angle. Okay, so in this example here, we have two sides. We have one which is the opposite and two which is the adjacent because it's right next to this angle, but we don't know what our angle theta is. Okay, we still go to Sohcahtoa, so we have Sohcahtoa, and here it looks like we have one which is the opposite and two which is adjacent. Okay, because we have those two things, opposite and adjacent, we're going to use tangent, but we can't quite just use the same method we had before. The equation's still true, so I have tan theta is equal to opposite over adjacent, and I can still plug in my numbers. I have tan theta equals 1 over 2. What I want to do is I want to get theta by itself. Okay, to do that, I have to essentially undo tangent. Much like addition undoes subtraction, multiplication undoes division, there's this button on your calculator that says tan negative 1. Okay, this is called arctangent or inverse tangent, and tan negative 1 undoes tangent. Okay, so if I do tan negative 1 of both sides, I will cancel out the tangent, and I'm left with theta is equal to inverse tangent of 1/2. Now what I can do is I can plug that into my calculator. And when I do that, I end up with theta is equal to 26.6 degrees. Okay, so for tomorrow's quiz, what you should be worried about is not finding the angle. We'll practice that in class, but you should be worried about finding the sides and knowing what Sohcahtoa means, what the equations actually are. I hope this has been helpful, and see you guys tomorrow.